we were discussing the concept of different kind of spoofing or the man-in-the-middle attack in general, and the overall outcome that I need to conclude here is we cannot only do the ARP spoofing or man-in-the-middle based on ARP spoofing, but also we can use IP spoofing and we can DNS spoofing. And DNS spoofing can be happened through an attack called DNS poisoning. And the DNS poisoning attack, the malware or the hacker may be able to compromise a DNS server or modify the user host file. And after modifying the user host file, he can go to this file and start to modifying or making like a fake record for a certain website. So assuming now I need to block my PC to access Facebook, for example, so I would update my host file to include value of invalid IP address or localhost IP address mapped to this host name. So I will try to save this file. I'm not sure if it's going to be saved as a normal file or not. So I will select this file and then I will click save. It is a read only, so I believe the problem here is that I need to open the Notepad++ as administrator. So I will open CMD once again. I will open CMD, right click and select run as administrator. And I will select Notepad application, and then I will select open. And then I will add this record, then I will save the file. So anyway, I will try to, let's say, modify this file name and add number 1. I will do a continue. And I will change this file name to, instead of being text, it will be like host only. So this is another way for modifying host file in case it deny or does not accept me to add data. And at the end, when I open this file once again, I will find that I have in this file a record for facebook.com. So I will try to do a flush DNS once again to clear DNS information that my device has learned about Facebook, for example. Then I will open my browser once again and will try to open Facebook website. It is opening, and I really don't know why it doesn't work. So maybe I want to test it on a virtual machine, or maybe I had something wrong in my host file. I'm not sure about this, but at the end, the threat actor may be able to manipulate the host file, and instead of mapping to the banking website, he may use your host file or use a special malware, and this malware may have the possibility to modify the host file. I will try to ping on Facebook. As you can see here now, when I do ping on Facebook, it is mapped to this IP address. Can you see this? Which is the IP address that I added to my host file. However, I'm still, when I try to open Facebook from my browser, to be particularly www.facebook.com, now it is not working. As you can see, when I try to open Facebook this time, it will tell me that there is an issue in website or in this website. It might bid you a certificate issue, But at the end, now the host file update has been changed and nobody on this device would be able to reach Facebook because I modified the host file. So host file provides the same function of the DNS in regard to mapping host name to IP address, but it will be significant to the local machine only. Also, regarding spoofing based on the IP address, could you give me an example for how I can do man in the middle based on IP spoofing? It is one of the easiest techniques, by the way, to do man in the middle based on IP spoofing. So, to explain it, in each network, we have clients. Is that correct? Users to this network, right? And we have a switch. And we have internet service that we need to reach. What is connecting users to the internet? Gateway, router, right? So as a hacker, I can attach myself to this switch. I can create a virtual DHCP server on my laptop, and this DHCP server will distribute wrong IP addressing information. So part of the IP information that clients of the network receive it from the actual network router, they receive value indicating what is the default gateway. In case they need to reach any service over the internet, they will need to communicate with what? With the gateway. Correct? By having hacker who run his own DHCP server on the machine or on Kali Linux machine, he will distribute new schema of IP addresses, including wrong default gateway. This default gateway will not be the actual gateway for the network, but could be the IP address of the hacker himself or herself. As a result, and without doing man-in-the-middle attack based on ARP cache poisoning, the information or all parts inside the network that need to go to the internet know that the gateway is at the hacker machine, not on the actual router. The only one on the network that know what is the actual gateway is the hacker himself. So whenever he receives traffic from users inside the network, he can inspect it first, extract valuable information, and then it will forward back the data to the actual gateway so users can access the internet. Clear? Yeah. Back maybe to 15 years ago or something like this, we got an application called Netcut. I don't know if you are familiar with Netcut or not. Okay, in my situation, back to 2005, the speed of internet was like 256 kilobit per second, which is very low speed. It is like, right now, it is like maybe 1 on 10 of my current speed. I have like 25 megabit per second speed right now. So to share this speed on multiple hosts inside the network, such as my device, my brother, my sister, and all of this stuff, it was very hard to deal with this low amount of bandwidth. So we were installing a malicious software called Netcut, and this Netcut use the ARP poisoning and deceive or spoof the ARP information for gateway to all users inside the network. As a result, nobody from the network will be able to reach the network gateway, but only the one who run the netcut on his device will know the actual IP MAC address of the gateway. So only the one who uses the netcut will be able to reach the gateway, but other users will have no access to the internet. That's why the application called the Netcut. It was an application that allow you to cut the internet out from all users inside the network, but not for spoofing their data or spamming or something like this, but only to take the speed of the internet all for yourself. And again, it was relying on the idea of the ARP and how to manipulate the ARP. Clear? So here I'm just giving you like a quick introduction about what is the Wireshark and how we can use Wireshark. I believe I discussed with you what does all of these elements mean. However, you are not required to understand a lot about this tool. But if you would like to get more information about it, you may see a lot of tutorials that are discussing how Wireshark work and how to do packet analysis using Wireshark. And if you can remember when I was discussing with you the elements of OSI model, I said application, I said session or transport session, then transport, then IP header, then layer 2 header, right? So that is the layer 2, that is the layer 3, that is the layer 4, and actually this is the data, which is the upper layer, which include data, application, and session and the presentation layer as well. So you can, even from Wireshark output, you can analyze each layer of the OSI model, which can help you in gain more understanding about how man in the middle or how OSI model really work. Okay. So how to protect against the man-in-the-middle attack using managed switches. Switches such as Cisco, such as HP, all of these switches have a capability called ARP inspection. And ARP inspection is a kind of control that help or prevent ARP spoofing from occurring. So whenever someone in the network send a message claiming that in case you need to reach A, come to my device, and in case you need to reach B, come to my device as well. The switch, if it has the capability of ARP inspection, he will prevent such attack because he will understand that this device, for example, has IP address of 192.168.1.1. So in case anybody in the network asked for an ARP information about IP address 1.2, this device should not respond to this request. The switch will be intelligent enough and has additional layer of protection to make it understand the IP address. So it is like an advanced switch, but at the end it is still a switch. But when you apply this feature or activate it, the switch will inspect what is your IP address. So why do you respond to the ARP request for a different IP address? You are probably making a man-in-the-middle attack or trying to spoof the ARP. So the request will be rejected. Also, regarding when I was discussing with you that man-in-the-middle or spoofing can be done based on IP, right? Such when someone gave a device that act as a DHCP server and start to distribute wrong data, fake gateway IP address. You remember this? So some of switches also has controls to detect if someone is trying to distribute IP addresses in an unauthorized way. So we have also some controls that it's called the network access control that do kind of security check to devices such as Cisco ICE. Aruba has a kind of network security control that do a posture assessment, which means before gaining access to the network, the user or the device need to be checked if it is joined to the company domain, does it have antivirus updated, and all of this stuff. End user awareness for the users to encourage them to not use public internet in cafes or airports whenever possible. And if you were subject to man-in-the-middle attack and the traffic between the website and the user was encrypted from the first place, no one will be able to read this data. For example, if we take the example of our lab, which was based on this scenario, which include like Windows 10 machine that was trying to communicate with a web server. The connection between the Windows 10 machine and the web server was based on HTTP protocol. You remember when I was discussing difference between HTTP and HTTPS? So the connection actually between this client and this website was based on HTTP protocol. That's why when I used the Wireshark on my Kali Linux machine, I was able to read the actual data that was being transferred between this client and this server. But if I am using secure protocol, I will not be able to read this data. So avoid to use any HTTP whenever possible. Use HTTPS instead. Avoid using SSL version 3, replace or use TLS. And even TLS versions include TLS 1 and 2, which are bad. And currently we have 1.2 and 1.3, which are good. Telnet is another kind of protocol that can be used to manage Linux system. And are you familiar with what is Telnet and what is SSH? Okay, so to give an example here, this is a Linux system, right? How can I manage a server that is running using Linux system? How can I manage it? By logging to the server itself and attach a keyboard and the screen, right? But this is a good option for management, or I should have a kind of utility that allow me to do a remote management while I am staying at the office instead of going to data center. So is it a good option? No, because it is better to have a utility, a tool, such as, for example, tools such as this one, POTI, which allow me to enter the IP address of the server that I need to connect to. Of course, if I have a network connection to it, and then I click enter, then I will get a warning message. I will click yes, and then it will ask me to do like login. So I will enter the username and password. And of course, this tool is tool used by system administrators, and we use it to access our servers to manage it remotely. So as you can see here now, I am from my own device using a terminal that allow me to log into the Linux system and manage it. This application is based on a protocol called Telnet. So Telnet protocol is a protocol that allow you to remotely manage terminals or command line interface system. When you manage router or switch, you can use a tool such as POTI. And you can select when you are doing the connection to either use protocol such as secure socket shell or to use protocol called Telnet. And both of these protocols will do the same task. It will allow you to remotely manage your Linux system. But what is the difference between both of them? The difference is essentially Telnet is a clear text protocol, which means any data that you will send to the server. Now I'm using Telnet, and I will open Wireshark. In Telnet is a clear text protocol, which means it is not encrypted protocol. So any data that you will send to the server using the Telnet protocol will be captured or can be inspected, or can be, in other term, can be captured by users or by hackers and so on. Yeah, Telnet is still an option. I am just trying to check which, because I have a lot of interfaces on my device. So I'm just trying to show you that what happens when I use protocols such as Telnet. So now I am capturing the traffic using Wireshark, and I will initiate a Telnet connection to the Linux machine. So the option exists because we may have some applications or systems that are not compatible with the SSH yet. Okay, so the option is in place as long as you are taking measures to ensure that connection between you and the device using Telnet will be secure. Okay, but in some cases and in some Cisco devices, Telnet could be the default management protocol. And you need, as part of the hardening of the system, to disable weak protocol and enable a protocol such as SSH. Got it? So anyway, here on this terminal, I will try to log in using Telnet. Then in Wireshark, I could filter on the application called Telnet. By the way, Telnet as an application, it used TCP port equal 23. That's why it is beneficial to understand what are the different type of ports. Because I can in Wireshark either write the word Telnet or write the word TCP port equal 23. Essentially, both will give me the same result because at the end, I will be able to detect or filter on the traffic of Telnet protocol. So now if I did like follow for TCP stream, I will see like what was happening during this session in clear text format because I am using protocol of what? Telnet. I can see the username and I also can see the password. Fine. Unlike using SSH. In SSH, we already has like SSH session in place, so I can filter on SSH. And when I do follow TCP stream, the same way that I did with Telnet, I will find unreadable data as you can see here. Because the traffic is what? Is encrypted. Fine. We could also have another protocol called the FTP, and it is related to file transfer. So it is a clear text protocol, while the secure one of it is the secure file transfer protocol. We can also hear about the term SMTP, which is related to email configuration. But this is clear text, and the secure one is the SMTP secure. But although SMTP is not secure, but we found a lot of Exchange implementations are based on SMTP, not SMTPS. That could be related to backward compatibility with the email client, software issue, unaware from administrators themselves, no security requirements has been introduced or has been considered during the design and the implementation, all of this stuff. In wireless as well, or in wireless communication, we may hear about WBA, WBS, or WEB, or WBA2. When you configure a wireless network, you usually find one of these words exist, and you can select which security protocol or which encryption mechanism that you can use. Now we should use only WBA2 because WEB, WBS, and WBA1 are all crackable tools or crackable algorithms. If your Wi-Fi network is based on WEB, your Wi-Fi network can be cracked in less than few hours. If your wireless network is based on WBS, your Wi-Fi network can be cracked in seconds. I'm not kidding here. That's why in Windows 10, for example, and in modern network and telephones, such as iPhones, Android, and so on, we will find that the support for web and WBS is already removed. While WBA is more secure, however, it is subject to be attacked and subject to be cracked as well. And currently, the most secure Wi-Fi type is WBA2. Okay? And of course, everything of all of this is subject to change by the time, which means now we consider TLS 1.2 is good. However, maybe next year, TLS 1.2 will be proved as a weak protocol and we should use TLS 1.3 only. So part of security objectives is to keep up with such data to understand what is recent or what is new practices or good practices that should be followed. Fine. So we have also some kind of cyber attacks, but these type of attacks could be related to websites such as cross-site scripting and SQL injection. And we will have two labs that describing how SQL injection and cross-site scripting works. But I believe this could be in tomorrow or in the fourth day when we will start discussing web application attacks. So we will have some interesting labs in these two parts. So leave it to tomorrow or next day. So we'll keep it. But I believe yesterday we got like a quick introduction about what is the SQL injection. It is an attack that targeting SQL database that allow hacker to exfiltrate data from databases. And for cross-site scripting, I can use it to steal the cookie file from the browser. Can you remember this part? Yes? Yeah. So we will do a lab for cross-site scripting and for SQL injection to see how significant such these attacks can be happen. Okay. So cyber attacks in general start by a phase called the discovery or reconnaissance. And during the discovery, we try to understand the footprint of a particular system. And then we start to prepare our malware or exploit. And then we search or look for a way to deliver this exploit to the target system. And then we exploit the system. By exploiting the system, we will install our malware, backdoor, spyware, and after then we can command and control this device remotely and do what we need to do with this device by asking or instructing this device to participate in denial of service attack or exfiltrate data from the hacked system. So what you are currently see here on the screen is like the cycle of the full attack, how actual cyber attacks can start and what are the different stages or the different phases of actual cyber attack. Any cyber attack should start with a phase called recon phase. And in recon phase, we are discovering the target system to check if this system has a Windows system, Linux, what are kind of software or applications that are running on this system. And we then check if one of these applications has a vulnerability. Yesterday, we saw how to get information about vulnerability. We, I believe, opened a website called Exploit Database or Exploit DB, and I showed you in Exploit DB that you can download the malware or exploit code that can exploit a specific vulnerability. Okay, so let's see together an example for a full attack cycle. We will start by scanning a device. After then, we will check what is the current systems or operating applications that are running on this device, how to get the exploit, how to deliver this exploit, and how exploit work, and what you are expecting to see after exploit went to successful. So in our lab, we will use the same machines that we were talking with or that we were dealing with during our man in the middle attack. But before starting our lab, I will just go to the Kali machine and I will disable the spoofing or will disable the man in the middle attack to ensure that ARB information will be stored correctly. So I will run ARB here, ARB command, to see how this device know about the rest of the network. Of course, he doesn't know anything about Kali machine right now. So assuming that I am a hacker inside a network and I need to start or do a kind of penetration to penetrate this web server or this web application. So the first phase, as I mentioned, would be to do a scan. So hackers first will start to scan the network, to scan against what are the current application or systems that are inside the network. So I can run a command called nmap, and the nmap is a Linux tool, Linux-based tool, that can do a scan for the network. to identify what are the running devices on this network. So instead of doing a ping to every IP address, we can do or use the Nmap tool. And by doing or using Nmap tool, the Nmap will start doing a kind of a scan to identify how many devices that we have inside our network. So we will leave it working for a couple of seconds and we will see the result. So usually, Nmap scan can take some times depending on the resources, the network resources, and so on. But at the end of this scan, we are expecting to have a result such as I have like 3 or 4 live devices on this machine in this network, and these devices are IP address 1 and 2 and 3. I will try to run the scan from another tab. So here in map scan finished, and as you can see, now we got the result. So we use the in-map scan without any switch or without any option to make the scan fastest as possible. And the result of this scan indicates that we have a device called 192.168.127.1. We have another device that is called 192.168.127.2. We have a third device that is end with 128. And this device looks interesting because we have a lot of services that are opened and running on this server. To make it clear to you, on this device we have port 21 is open, port 22, port 23, 25, 53, 80, 445 or 445, which means this device is working as a file share server. It can also work as HTTP server, a DNS server, SMTP server, Telnet SSH, and FTP, which means there are a lot of applications that are running and available to be accessed from outside this device, and this could give us opportunity to find a vulnerability in any one of these devices. So based on this scan, I identified how much devices that I have inside this network and what is the possible device that could be acting as a server inside this network. And in this case, this device will be this IP address. So I can do more in-depth in map scan, but this time this scan will target this IP address only. So as you can see here on the other in-map scan, I will doing a kind of advanced scan that do a kind of enumeration to detect what is the running application on the devices or on servers inside this network. So when I did this scan on 192, 168, 127, and 128, I discovered that I have port 21 open, and this port has an application called VSFTPD version 2.3.4. Let me know if there is something not clear till now, or the process is not clear. So what I am currently in is first I do a general scan to identify the host exists in the network. The goal is to do a kind of footprinting, understand which one of these systems could be a potential server that I might be interested as a hacker to spend the time in trying to penetrate it. So based on the number of open ports, I could identify that this server may be a web server, maybe a database server. So when I penetrate it, I may cause a greater impact because I may exfiltrate sensitive data. So I can take this IP address after a while and do another scan, but this time this scan will be more advanced and it will be a scan that is targeting to detect what are the running services and what are the applications that could be available to view, or in other words can be reached on this server. So this scan happened in the first tab, but instead of making this scan for a particular server only, I made it to all hosts inside the network as well. That's why the first scan took much time. So the advanced scan on this IP address show me that we have on port 21 service running called VSFTPD version 2.3.4. So I may take the name of this service and open the website that we discussed yesterday, which is called ExploitDB. And in ExploitDB, I could search for an exploit, and in search option, I could search for this name of application. As I can see right now, we have an exploit to this software version, and it helps us to create a backdoor or gain access to any server that is running this specific version. In order to use this backdoor, I need to download this exploit and move it to my Linux machine, and then run this exploit using Ruby tool. And after then, I can use this exploit to exploit the machine. But instead of downloading and copying this data to Linux machine and all of this stuff, all what you have to do is using a framework called Metasploit. And the Metasploit is like an automation tool that help you to run or conduct attacks and automate the exploitation of system vulnerability. So when you open the Metasploit console by command msf console, you will leave few minutes for it in order to load. And after it is being loaded, instead of going to GitHub and search for the exploit, I will search for the software name on this utility itself. So I will do a kind of search for the same software name. So Metasploit will tell me that if it has like exploits for this particular software, which I can after then select to use it, and then I will define the IP address that have this or that has this version of software installed, and then I will launch the attack. So Metasploit essentially help you in the weaponization process and delivery process, as well as in exploit process. It helps you by giving you the payload required. Of course, if this application has like a signature or payload on Metasploit, it helps you to deliver this application or this payload, and it helps you as well to exploit this vulnerability. So back again to our lab, Metasploit is now running. So I will do a search for the application that was called VSFTPD. So I will write search VSFTPD and then enter. It will reply that I already have an exploit for Unix system for application called the VSFTPD 234 backdoor. I will copy this value and I will write use, then I will paste the name of the exploit. Now I will be redirected to the properties of this exploit. So I need to set some parameters first by doing the command set, and it will ask me to set the R host. And what do we mean by R host is the target IP address. So I will set the R host to be the IP address of the machine which we detected this running service on it. So I will write the set R host 192.168.127.128. Then I will write exploit and we'll click enter. What is happening right now is that my Linux Kali machine is delivering this exploit, and it already exploit this vulnerability, and now I have a command shell session opened, which means if I took this IP address and from my Kali machine, I tried to route SSH, and then I wrote this IP address, or let's say telnet, then I pasted this IP address, and then I wrote the port, which is mentioned after, then I will have an access to this server. To prove to you that I have access to this server, I will try to create a new file that's called Ahmed June 2022. When I go back to the Metasploit machine, which I had exploited, and when I do a command such as ls, so it seems that it doesn't work. So anyway, from this machine, I will write dir. So I have a lot of data, so I will write here. As you can see here, when I wrote the command dir, I found that there is a text or a folder called Ahmed is here, tech vortex, VM Linux. If I made another file such as make dir Ahmed June 2022, then I came back to the original server and made dir, I will find the directories that I created are here now on this server. So that's a proof that through Kali Metasploit, I was able to exploit this server and gain access to this server. Moreover, I can shut down this server by sending this command from Kali Linux, and as a result, the system itself will start to be powered down. Okay? So this is an explanation about how threat actors can scan a system to find a vulnerability. Of course, we have a lot of tools that can help us in detecting system vulnerability, such as vulnerability assessment tools. Tools such as Nessus is like a vulnerability assessment tool that help you in more comprehensive check to check if your system has a kind of software vulnerabilities as well. In addition, of course, to Metasploit, in addition to Nmap, and all of this stuff. I hope that's clear so far. So here we have like a description for what we have conducted so far. So first we scan the network to identify juicy targets, which may have a lot of sensitive information or interesting information. We make a deeper level of scanning to identify running services. We identify possible vulnerabilities, and we search for exploit to trigger this vulnerability, and then we exploit and gain access. We check the privilege that we have so far, and we can after then do whatever we want on this target. Okay? Okay.